Hey everyone, I'm really excited that you're here for improving Spark for dynamic allocation and spot instances. I'm Holden Caro. You can follow me on Twitter. It's just my full name. And yeah. So as I said, my name is Holden Caro. My preferred pronouns are she or her. It's tattooed on my wrist. I'd show you, but it turns out that I also broke this wrist. And so it's kind of a pain to show. I'm on the Spark PMC, which is really awesome. I'm really honored to be a part of the Spark community in this way. And I also contribute to a bunch of other Spark projects. I'm a co-author of a few books about Spark and some other books as well. I, of course, think these books are wonderful, but I might be a little bit biased. In addition to writing books, I also do a bunch of YouTube videos, mostly around Spark, but I also do some other tools like Dask and stuff like that, and some Kubernetes stuff. And so if you're interested in seeing those videos, definitely check out my YouTube. In addition to sort of the professional related stuff, I'm trans, queer, Canadian, in America on a green card, finally. That took a while, and part of the broader leather community. And so you might be wondering, why would I bother bringing this up in a data talk? And it's because I think it's really important for us to talk about where we're all from, because we perhaps have some opportunities to improve the diversity of our communities. And part of that is going to involve talking about where we're from, seeing, what sort of people aren't being represented in our conferences or in our PMCs or committer groups. And so I think it's really important for us to all sort of talk about our backgrounds and make sure that we create a diverse community so that we can, solve problems that are fun and make the world a better place, which is presumably why some of you are here. So with that slight segue, I want to start at sort of the beginning of why this is a problem and why I decided to work on this. So Spark is really wonderful, and it achieves resilience by recomputing anything when we have failures, right? And this is sort of compared to the classic model, which Spark replaced, MapReduce, where we achieved resilience by writing data out multiple times. And this is really great, right? Because writing data to disk 3 times is kind of slow compared to just storing it in memory. And if anything goes wrong, just recompute it. The problem is when executors are removed that contain data, right? In traditional MapReduce world, that wasn't a thing that mattered because there was no data inside of the executors that mattered, right? Everything was stored in a persistent storage layer. So we could remove executors all we wanted, either for dynamic allocation or if we were running on spot instances, it was fine. This is different with Spark, and we solved it for the cluster managers that we used to use, or sorry, still use today, Yarn and Mesos. And many, many moons ago, I drank a lot of coffee and I came up with an alternative idea. But it turned out that we didn't really need this alternative idea that I came up with to solve this problem. And so it didn't really go anywhere, despite all of the delicious, delicious coffee that I drank. It just kind of landed flat on its face. And I closed the Google Doc and sort of forgot about it. And you might be going Holden, this is a very long story, but I assure you we'll get to the code soon enough. A few years after I'd given up on these changes, the cloud became really very popular. And then Kubernetes also became really popular, and then everything caught on fire. And mostly for that inside of Spark, what I mean by everything caught on fire is that our traditional model of achieving resilience, while it was really, really fast, had some substantial downsides. And so we found ourselves spending a lot of time recomputing data. And so that's, not a pleasant fire. Thankfully, I had a lot more coffee again. And I remembered that I'm very lazy. So whenever I'm faced with a problem, the first thing that I do is go hey, I bet someone else has solved this problem before, and maybe they've solved it. And it turns out that I'd had this problem before and I'd thought about it. And so I found the search results in my own search history. And I was oh, okay, cool. I guess I'm gonna work on this thing. And I started writing some code. And then I got hit by a car. And I wanna say, getting hit by a car is not a lot of fun. Do not recommend. I broke both of my wrists and spent a week at SF General, and some more time in a nursing home. Really, really nice people there, I gotta say. But still, not a pleasant life experience. The really nice thing though is people kept writing code even though like I was gone. So that was kind of cool. And then we ended up having a vote to see if this was the kind of solution that we wanted to have, like if everyone agreed this was what we wanted to do. And thankfully, everyone agreed. And then we wrote a lot more code. And then in theory, everyone lived happily ever after. But in actual fact, there's a lot more work to do. And I would really, really love your help. So with that being said, for a little bit more context, how did we do dynamic allocation on Yarn? So scaling up with a model like Spark is relatively easy, right? Our problem only occurs when nodes are going, whereas when executors are going away. Adding more resources is a-okay, right? It's very much like budgets. Adding more money to a problem, taking the money away, very sad. So scale down. In Yarn, how we handled this is we had a stay resident program on each node in the Yarn cluster that would serve the files left behind by any executor that may have been exited or killed. And this worked out really well because Spark stored its shuffle data as files. It did, of course, lose data that was stored only in memory, and some types of data was cached in memory and not actually written out to disk. And so that was still lost, but the shuffle files tended to be the most expensive parts. And so this was a really good solution, and it didn't require like huge architectural changes. And so that's how we did it on Yarn. The problem though is if we deployed Yarn on top of the cloud, Spot and preemptable instances give you really big cost savings, like around 50%. Like the exact details, of course, change depending on your vendor, talk to your vendor. But if we think back to sort of the solution that we had for this problem in Yarn of leaving a stay resident program, we can't leave a stay resident program if our entire computer is going away, right? And so the cloud sort of had some strong limitations with this. So we needed to find another way to make sure that data was still available and we didn't have to recompute it. Okay, so let's say that makes sense for the cloud, but what about Kubernetes? Surely, if we were deploying Kubernetes on-prem, we wouldn't have to worry about this. And it turns out that even if we're deploying Kubernetes on-prem and we're not using Spot instances, we do have to worry about this. And that's because Kubernetes isn't super down with the idea of a stay resident program on every node that serves files. And it turns out that in the interim, for a combination of reasons, including sort of, just general security concerns and quota management, people were much less excited about the idea of setting up shared disks that span between jobs and users. And so that also limited the ability to sort of essentially repurpose the Yarn solution to Kubernetes. For one thing, didn't support it very well architecturally, and for another thing, the security people weren't super excited with it anymore. And just for a little bit of context here, because I got hit by a car while I was riding a scooter, and actually this is me being very happy and excited in front of a bunch of scooters. I still love scooters. And these scooters were at KubeCon in somewhere, Italy, I think. A lot of fun. I really look forward to the day that Data AI Summit it comes back to in-person events and I can actually see all of you in person. This is nice, but I miss catching up with y'all in person and also, getting a chance to ride scooters in foreign countries. Okay, so that's not particularly related, but close enough. So how did we solve this problem? So we copied the data, and we're going to look at the code very, very shortly, I promise. But the first thing that we're going to do is we're going to look at this Jira issue right here. So I said we're going to get to the code really soon, and I promise we are. But I want to take a quick, just a super, super brief detour to the Jira issue that has a lot of the code inside of it. And that's because the solution to all of this problem is copying the data. And copying the data sounds like a relatively simple thing to do, right? Especially like if you weren't like super familiar with the internals of Spark, you might be like, oh yeah, that makes sense. Like not just CP, that's all I have to do. But it turns out that like copying the data is actually pretty complicated. And we can see that the simple task of copying the data was broken up into these 23 subtasks, not all of which are done. Enough of which are done that it works, but it's pretty involved. So this thing does not particularly like it when I try and do this, but we're gonna hope, fingers crossed, that Emacs isn't gonna crash on us. And that's just because Emacs in full screen sometimes misbehaves on me. Most of the magic happens inside of this class called Block Manager Decommissioner. And so as we see from the description, it's a class to handle block manage or decommissioning and the retries. And it creates multiple threads to offload both RDD cache and shuffle blocks. And so as we talked about, the Yarn solution was really focused on shuffle blocks because the shuffle blocks are the most expensive part to handle. And I'm gonna zoom in a little bit just because I know that reading text can be a little bit hard. The main magic here is all inside of this thing called shuffle migration runnable. And what this does is we fire up a bunch of these, one for each potential block manager that we could migrate our data to. So if we know that a executor is gonna be exiting soon, for whatever reason, be it dynamic allocation, be it or the spot instance is going to be preempted, we get some notice that essentially like we're going to die soon, like our code, not us. And we try and get as much of the data off that machine as quickly as we can. And so here we have a producer consumer model with some limited retries, and it does back off if there's an IO exception, for example, because we might get IO exceptions if the other host we were trying to migrate to was also shut down, or if the host we were trying to migrate to ran out of disk space. And in that case, retrying it isn't going to be effective, and we just want to put the block back on the queue really quickly for another potential candidate block manager to pick up and try and get it. And we can see here that the blocks are actually comprised of subblocks, and that's because this only supports the indexed shuffle blocks right now. And so there's both an index and the underlying block, and so we migrate all of the blocks. And there's also, and this is really important, this fallback storage option, and that's very important because if we only migrated data between different executors, we couldn't scale down all the way to 0 or even like 1. We would have to be able to make sure that the minimum number of nodes we were scaling down to still had enough disk space to store all of our data, right? And if we're doing big data, which is probably why we're using Spark, that might be quite a number of machines. And we might actually have a situation where, you know, especially for a notebook user, that's just really not what we need, right? And so here, this fallback storage allows us to sort of go a little bit more back to the old MapReduce style model. And what we do is we copy the data out onto HDFS or S3 or some other kind of persistent store where it's not tied to the compute in the same way. And so we can scale down our compute much more than the initial design that I'd come up with 5 years ago. And shout out to Dongjun for coming up with this design with the fallback storage as a copy. And there's a bunch of like little fiddly bits, and just as a shout out, I got a lot of these little fiddly bits wrong initially. And I think this is one of the magics of open source is there were so many code reviews, and we'll actually look at some of the code reviews in a little bit, that we managed to fix all of these little tiny things that I'd gotten wrong that looked okay in testing. But there were actually many logic bugs in the first implementation of this, where like under certain circumstances, we wouldn't actually migrate all the files, just most of them. And so that's really lovely. Shout out to all of the people who do code reviews in open source. Thank you for taking the time to do code reviews. you are amazing people. But we can also see, like, in addition to migrating shuffle blocks, we migrate RDD, cache, or persist blocks. We don't follow the same model here as we do when we're migrating shuffle blocks, and that's because the overhead of recomputing these blocks tends to be not as high, and so it's not as worth it to sort of shotgun, approach copy data out to as many potential peers as possible. So in this case, we just really copy one block at a time with the RDD blocks, and that's that's pretty rocking. And yeah, this is the thread pool that we use for our shuffle migrations. We can see the producer side of the producer consumer is inside of this thing called refresh offloading shuffle blocks. And that's for if shuffle blocks are added while we're in the process of exiting. And so we do have some logic that tries to limit the number of times that would happen, but it might happen if there was an existing task running on an executor. And so that's where the producer side is. And then we have this like stop function, and that just says like, hey, we're actually done trying to migrate. Let's give up. And then this code is also, I had a logic bug here, got caught in code review. Thanks. Or was it caught in code review? It got caught by someone else at some point. It might have been code review. It might have been a follow-up PR. But I essentially had wired some of the stuff in backwards. And so it was succeeding, but it was only succeeding because we were able to migrate things relatively quickly. And so anyways, it's been fixed by now. But it's a good thing to tell, right? Like if I'd just been working on this by myself, there would be all kinds of bugs here. As it stands, there's still probably some bugs, but much less, right? And yeah, so this is the part where what we do is we keep track of, like, have we migrated what we think of as all of the shuffle files? And we don't just exit at the point where we believe that we've migrated all of the shuffle files, because the block manager doesn't know if there are any running tasks on the executor that the block manager is associated with. And so what we do is we just update a timestamp that says, as of this time, all of the blocks that had hit disk or hit memory have been successfully migrated. And then we have another piece of code somewhere else which checks that and says, like, hey, when was the last time I had a running task? And if we've got a situation where the last running task was less than the time that we migrated everything, then it's safe to exit. But if we have a currently running task or running task finished after the last successful migration completed, then we continue to wait until the migration refreshes itself again and finally migrates everything. And so I really like this code. I think it's really cool. I hope you do too. If you found any bugs in it during this conference talk, I would love a PR fixing those bugs. Or if you find any bugs when you're using this code, like, please, PRs are really, really welcome. I would really super love them. Okay, so on that, we are going to go and I'm going to talk a little bit more about the collaboration part. So I'm going to jump back to my slides just super quickly. So I really want to talk about the collaborative aspects some more, in addition to, like, looking at the code and calling out some of the places where I remember the mistakes I'd made. And so I think one of the things that's really awesome is we have this, okay. And we got some ads, but we can see here that I brought up this proposal. It's called the decommissioning SPIP. We can see the design document that exists, right? We can see comments from different people. We can also see, yeah, this is the full design doc. And we can see that there's a lot of comments from a lot of different people here, right? And this is really wonderful. I think that these comments had a lot of really great suggestions and really improved the quality of the eventual code, and is sort of some of the magic of open source. And it's part of why I really love working in open source, right? Is like, I get to work with all kinds of smart people, and it's really wonderful. And like, oh yeah, here Devesh made a PR for one of the parts. Wonderful, different company, right? But made a PR for this work here too. And so I think that's pretty cool. Another thing that I want to do really quickly is GitHub dot. I really want to also just take a super brief look at all of the different PRs around decommissioning. And some of these are less related, but we can see like that they're from a variety of people at a variety of companies, right? Like better metrics for tracking dynamic allocation. You know, we've got things from Databricks, we've got things from Cloudera, we've got things from Apple. We have things from all kinds of different community participants. And so I think that's really awesome. You know, and I don't know. Maybe I'm kind of a sap, but like I really think the magic of open source is we don't talk about it often enough. I like it a lot when features like this are implemented, not just from one company, but from all kinds of different companies collaborating. I think those are the times when we make some of the best features in Spark. Now, I am of course biased because like, you know, this is a feature that I was involved with. So, you know, I might think it's the best and you might go like, hold, no, this isn't the best. But yeah, okay, that's pretty rocking. Back to things that are less fun. So getting hit by a car sucks a lot. And here we can see me walking around SF General with my very wonderful braids, actually from my friend who came down and helped braid my hair because I'd broken both of my wrists and I really couldn't do anything. And I just want to take this time to thank everyone from my wife, my girlfriend, partners, my friends, my parents, the hospital staff, the nursing home, the physical therapists, the occupational therapists, the ambulance people, my employer, and also everyone in the Spark community for understanding. I sent out an email that was like, hey, what's up? I got hit by a car. I'm really sorry. Well, actually, I think I had my wife send the email for me because I couldn't type. But everyone was really understanding of the fact that like, yeah, you know, you're working on a thing, but at the end of the day, like you got to look after yourself. And I think that's something that I want to remind other people, like, you know, it's been a rough year for everyone. Don't feel bad about taking time to look after yourself. Like I love open source. The stuff is really cool. You can do some really awesome things, but don't push yourself. If, you know, if you're burnt out, take some time away. If you're physically injured, like it's okay to not be as productive as you might always be. And so, yeah, shout out to everyone for understanding that. And we're gonna go back on a happy note. You can try this stuff out now. And this is so cool. So I really, if you run Spark, either on Kubernetes or in the cloud, even if you run Spark on Yarn, you can turn these features on. Although to be fair, it doesn't really give you as much as with Spark on Yarn, but I would love it if you were to try these features. They are very new and very experimental, but you can turn them on today and you can start taking advantage of some of the benefits. So you'll turn on these, all of the ones where it says enable, you want to set it to true. And then you can optionally configure a backend for the external storage level. If you've got S3 or something like that, where it's got TTLs to automatically clean up the data, I think that's really the best option for the backends. And I would love y'all's feedback and bug reports here. Like, I know we won't have gotten it perfect. I know that there's going to be mistakes. So please use this, tell me what's wrong with it, and we'll try and make it better. And if you want to help us make it better, there's some things that we know we need to do to make this stuff better. So one of these things is that right now, data migration, we just migrate everything. And I think there are some basic heuristics inside of Spark around the importance of data. They're not great, but I think that we could have really much better performance if we migrated data that was more likely to be used. And so if you're the kind of person who likes writing heuristics, please write some to help us decide which data to migrate first. Another one is if you're a like cloud native or container person, I really think that's something that we could do that would have a really big impact for the Kubernetes users is improving the container preemption selection. And this comes from the idea like, yeah, we can set static priorities, like we can set the driver at a really, less likely to be preempted priority, and the executor is at a like higher level of likelihood to be preempted. But not all of the executors are necessarily equal all of the time. And so I think improving how we tell the cluster manager, not the Spark cluster manager, but the Kubernetes cluster manager, which containers are least impactful to us to lose, could be really beneficial. Another one that I noticed is we could really use better heuristics around when to scale up and down containers. And this is not specific to this work, right? Like you don't have to be a cloud native or Kubernetes user. If you're on Yarn, for example, I think better heuristics for scaling up and down containers is a really good place for people running on those systems to contribute, because that will benefit people running on all cluster managers. Because I think right now our heuristics there are not perfect either, and we have a lot of room for growth. In fact, one of my coworkers did some testing, and we have some configuration knobs that are tunable, and it turns out that like you get vastly different performance based on what you set those numbers to. And I think we could probably, even for like a non-code change, writing a blog post about how to properly set this stuff could be an excellent place for someone to contribute who doesn't want to write code, but is more interested in like writing a blog post. So with that being said, I'd really appreciate it if you could review this talk. I would love to come back to the next in-person Spark Summit. And one of the ways that you can help make that happen is tell people that you liked my talk. If you didn't, of course, there is no need to review this talk, or of course you can. You can also reach out to me with feedback about ways I can improve. I actually do read that stuff because I like giving talks, and if there's things that I can be doing better, definitely give me a shout. Big shout out to my employer for giving me the time to work on not only this talk, but all of the Spark stuff. They are hiring, and I think there's a bunch of other wonderful talks from my coworkers as well. And if you're interested in learning more, feel free to reach out to one of us about what it's like to work at Apple on Spark. Thank you all for your time. Have a lovely day.